Well, it's time. We're finally going to talk about the CPU you've all been waiting for. I'm talking about
Intel CPU that doesn't suck?
No, it's not that one. I'm talking about
Intel CPU that can play video games?
No, it's not an Intel CPU at all. We're talking about an actual CPU that does what it's kind of advertised to do. For those looking for a high-end custom gaming experience, look no further than Falcon Northwest. Falcon Northwest has been building PCs made for gamers for over 30 years with a focus on a true high-end gaming experience. Custom cases available only through Falcon Northwest feature state-of-the-art testing and design to ensure that every component is performing at their best through thermal imaging and rigorous lab testing designed and overseen by the Falcon Northwest founder himself. With a complete lineup of systems ranging from small to large, every Falcon Northwest system includes a 3-year warranty policy and a year of 2-way overnight shipping coverage, providing the ultimate peace of mind. To see all that Falcon Northwest has to offer, follow the sponsored link in the description below. Talking about the 9800X3D, the GOAT of gaming, or is it the new GOAT of gaming? It is one of the most anticipated CPUs I think that anyone has been looking forward to this entire refresh cycle. And we've been playing around with it for like the last week or so, and I can tell you right now, it's actually a pretty fun CPU to play with. There's a lot of architectural changes. It actually makes it better for enthusiasts too, not just a one-trick pony of plopping into your PC and calling it the best gaming CPU that you could currently buy in 2024. Now, in terms of the timing, if it looks weird behind me, that's because we got bored of the new studio. Actually, to be honest, we got tired of the stairs. So we went ahead and moved back to our old unit, and that's it. We're just gonna throw away the money we spent on that, and here we are, back in the old place, so it should look familiar. Anyway, moving on, we're gonna talk about the second generation 3D V cache from AMD. There are some new AMD Expo speeds you can sort of expect when coupled with the X870 chipset, but more importantly, there's just actually there's a lot different when it comes around to this particular generation of the 3D V cache technology. So the real comparison here is going to be how it stacks up versus the 7800X3D, because that has been the GOAT gaming CPU, as you guys know, up until now. Really kind of a one-trick pony. 8 core, 16 thread, single core complex, CCX, CCD. Not great in multi-threaded tasks because honestly, when it comes to thread count, by today's standards, 8 core 16 thread is kind of like mid-range, if you will. In fact, the 7800X3D even underperformed versus the 7700X in a lot of like compute type of workflows, because it just really heavily depended on workflows that would utilize extra cache when it comes to the CPU. That's more often than not gonna be a compute type of compiler type of workflow. That's gonna be games when it comes to a massive amount of frames being thrown at it. But one of the things that really limited the 7800X3D, in fact, any 7000 series X3D, including the 7900X3D and the 7950X3D, it's not just the fact that those multi-CCD CPUs only had the 3D V cache available to one CCD and not the other. It was the temperature sensitivity. Now, up until now, myself and a lot of others also believed that it was the cache that was sensitive to temperatures, which is why we saw a reduced TJ max temperature from 95 down to 89 C. Power limits also reduced significantly on the PPT because of the fact that we just assumed it was the cache that was sensitive. And the reason for that is the cache was on top of the core complex. So I think the initial design when it comes to this, 3D by the way means stacked. It goes at a Z-axis higher, whereas Intel's adopted a tile design where they kind of go wider and everything is on the same plane with the interconnect underneath it. Now, the core being under the cache on surface seemed like a good idea because you have the cache immediately accessible to the core. The problem is you're kind of creating a thermal insulation issue here where the core, which is actually more temperature sensitive than the cache, was being thermally insulated by the cache itself between the IHS, or the integrated heat spreader, which is designed to pull the heat from the core and get it to your cooler and get it out of your system. The problem is that process happens a lot slower and a lot less efficiency when you have something other than thermal interface material between the core and the thing taking away the heat. The cache didn't even fully cover. It did not even fully cover the core itself, or the core complex design. So you had a filler that kind of went around the outside of it to fill it in, which was to do nothing other than to make it a flat surface for the cache to touch, and all that did on the side was also just completely insulate the CPU. It was actually a pretty poor design when it comes to the thermal aspects of getting heat from the bottom side of the complex to the top side of the complex. It's like your heat had to take an elevator, a very slow elevator to the top of a skyrise to get to open air. So what did AMD do? They flipped it. They flipped it and reversed it. So what they did was they made the new interconnect cache on the bottom. It's the full cache array on the bottom of the core complex, or the CCD or the CCX, whatever you want to call it, so that now you have the sensitive side, which is the core, touching the IHS directly, which is giving you better thermal conductivity, so you don't have that lower TJ max, you don't have the lower power limits, actually the power limits are the same this gen versus previous gen. We'll talk about that in a later part of this video when we did our power testing. But now you have the core back to touching the IHS as it's supposed to. In fact, it's a very complicated type of manufacturing when you're doing 3D V-cache. So it's not surprising to me that the 3D V-cache CPUs are as expensive as they are, because there's probably lesser yields, and it's even more complicated in assembling a Big Mac of silicon, if you will. Now, because of this new flip design means we have better thermal conductivity, as I've already said, which means less sensitivity, which means they can bump the core clocks up. They can also let it go to its max power limits quicker and longer and more sustained and stay there. So obviously more core clocks is going to equal more performance. Now, because this is also on the latest Zen 5 architecture, means we're getting better IPC as well on top of all of that. So between the 7800X3D and 9800X3D, they're both 8-core, 16-thread, although the max boost speed for the 7800 was 5 gigahertz, whereas now we're at 5.2, and the base clock gets lifted 500 megahertz from 4.2 to 4.7. They both have the same 8 megabytes times 1 of L2 cache and 96 megabytes of L3 cache. Both are 120 watt configurable TDP thermal design power, which really doesn't mean anything these days, because both of them have a default socket power PPT limit of 162 watts. TDP, as you guys know, is kind of just a marketing number at this point, because of the fact that there's more to it than just TDP when it comes to power rating. Both are 180 amps, both are 100 of max current, both are thermally limited to 120 amps, et cetera, et cetera, et cetera. Now, as I've already said, the 7800X3D has a temperature limit of 89. That's pushed back up to the standard Ryzen temperature limit of 95 when it comes to the new CPU. Now, what you're gonna find out is actually, it doesn't even need it, because now that you've actually got the die like almost even closer to the top of the IHS, it's almost like they have less material in there, although it is gonna be like an indium solder. It runs very, very cool. I'm not saying that as in like, it's totally cool, bro, but it's actually a very cool CPU. With that said, let's go ahead and move on to our charts. This is the part you guys care about more than anything. No, they may not be Gamers Nexus levels of charts, but they are charts nonetheless. All right, so starting off with Cinebench 24 single thread. Remember, the CPU we care about most as we're doing a generational comparison of how the almost said X3D, the 3D V-cache or X3D CPUs have sort of gone from first gen to second gen is 7800 versus 9800 X3D. So as you can see here, our single core, higher is better when it comes to the score, is pretty big jump. The 7800 was at the bottom of the chart at a 113. That's gonna basically be because of the clock speed uplift as well in single thread. But when we look at the all thread score, we go from a 1088 up to a 1346. Now that may not seem like a lot, but the way R24 is designed and the way it operates is even just a few numbers is a fairly decent jump when it comes to that test. That's why the bottom and top here is a difference of 1088 versus 2626 on the scores. So the fact that we're seeing any sort of compute uplift at all with the same core count, the same thread count is a good thing. When we look at the R23 single thread test, again, they jump up from 1815, this time all the way up to almost the middle of the pack of a 2085. So pretty significant jump on the multi-threading. Again, 7800X3Ds at the bottom at 18,055, moving up to a 22,986. That's like an entire CPU jump. It's like an entire tier of CPU jump just in generational performance. If we take a look at Blender, again, higher is better. These are samples. This is a sample rate. It goes from the bottom of 118.4 for the 7800 up to 146.13, so a fairly decent percentage increase there. Junk Shop. Same exact story, 8316 up to a 10373. So we see nearly a 25% jump in performance here just from one gen to the next. Classroom 5722 up to a 7236. So again, a very significant percentage jump from previous gen. Don't worry, we'll get to the games in a second where it will start looking a lot less depressing. I don't think anyone was expecting, as we're comparing it all the way up to a 9950X, that it was gonna look great in these types of tests. It's still a one-trick pony. It's just getting a lot better at its tricks. Give it some time. I'm looking at you, 9950X 3D, hoping you have 3D V-Cache on both CCDs and a full turbo boost available to you. Moving on, 7800X 3D on the one thread Geekbench. Goes from a 2752 all the way up to a, number 5 on the list at 3303. So a big jump in that one thread on Geekbench. Now, as soon as we go to multi-core, we go from a 15,194 up to a 18,243. So a gain of over 3,000 points in multi-threading. Not bad. Again, not the reason why you would buy this CPU, but this is why we compare them in both kinds of use cases here. Because if we look at Handbrake, where lesser is better, we go from a 96 seconds of a 7800X3D down to a 82 seconds for the 9800X3D. A drop of 14 seconds, a good chunk of percentage drop. However, not anything to write home about. It's not why you buy this CPU. If we look at Times by Extreme CPU test here, again, higher is better on this one. We go from a 5918 all the way up to a 7450. 1,500 point jump, but again, these are the bottom 2 CPUs on this chart because again, Times by Extreme CPU test highly favors threads. But as soon as we go into the arena at which the X3D is intended to compete, it's a pretty decent slaughter as far as I'm concerned. That's 9800X3D and Shadow of the Tomb Raider RTX 4090 FE. By the way, AMD, need to make a note. It's RTX 4090. In your entire deck, you call it GTX 4090. I do think that's the kind of thing that should be noticed and fixed. Although coming from me, that probably looks even worse considering I am the king of typos and titles and everything else. But anyway, we go with Shadow of the Tomb Raider at 384 average FPS with the 7800X3D in second place at 42 FPS less at 342. So a 342 up to a 384 on the average FPS. That is a pretty bonkers jump right there. Okay, so Cyberpunk 2077. Again, RTX 4090 FE, 1080 medium, no scaling, higher is better. We go from a 253 average, 195 minimum, up to a 278 average, 218 minimum. So mins come up, average comes up, no surprise there. It definitely, it fills in the gap perfectly between our overclocked and CU dimmed 8400 megahertz 285K on here, which is only on here just to show how crazy it is. It's overclocked and CU dimmed and cache pushed and all that crap. It can't even come close to these X3D CPUs. But moving on, the Borderlands 3, 373 FPS average on the 7800X 3D, up to a 436, which is just nuts. In fact, for a minute there, when I was doing the 285 testing, I thought that maybe there was an engine cap right around 370-ish FPS because of the fact that there's 372, 373, 369 right there. But 9800X 3D said, hold my beer. Here's what 436 FPS looks like. You know it's actually doing well when I have to actually redo the axis on my charts because it goes off the end of the chart every time we input the data. If we look at F1, same thing here. It's minimum FPS of 459. Not even talking about average yet. It's minimum of 459. It is higher than almost every CPU on this chart, including 14th and 13th gen 900K CPUs, average scores. So 459 minimum FPS, 544 average FPS in F1. What's interesting about that is if we actually look at the charts that AMD gave us for like sanity checking, if we're seeing if things are landing where they're supposed to, it was one of those that it showed basically like parity with the 7800. It didn't even show that there was gonna be much of an improvement. We saw an improvement here. That's at 1080p medium, again, no scaling, higher is better. So big jump for F1 in our test bench. Horizon Zero Dawn, again, we go from a 289 to a 306. Not a huge jump, but a jump nonetheless. It's one of those things where we would all love to see 25% improvements in every single iteration of CPUs. Some of these are in the single digit percentage improvements. Some of these are bigger than others, as high as 20%. It really depends on many, many factors. It depends on how good is the cooling for your CPU, how hard are you hitting any sort of temperature limits, how up to date are your drivers on your GPUs, how up to date is your game, how up to date is your Windows. There is a lot of factors that play into how much improvement you're gonna see from one gen to another. It is actually just nice to see though, that we're seeing a CPU give us a generational improvement in performance rather than a lateral move or a regression in terms of performance like we saw with Intel's latest Core Ultra CPUs. Now what's funny is if you compare this to the 9950X, 9900X, 9700X, and 9600X, all four of those CPUs saw anywhere from like 4% to maybe 10% improvement in compute, very little to no improvement in games, sometimes 5% faster or so. So I think we're getting to the point that as the process gets smaller and smaller, it's becoming harder and harder to get the double-digit plus generational improvements we're expecting to see. But at $479 launch price, it puts it $30 above what its actual 7800X3D counterpart or previous gen launch was. Right now, 7800X3D on Amazon is $476. So there would be zero reason whatsoever to buy a 7800X3D if you can find a 9800X3D not being basically price gouged on day one, because you know it's probably going to. I have no idea what the amount of availability of these are gonna be. I have no idea how much allocation is making it to Amazon versus Newegg versus Walmart versus Micro Center versus Best Buy. Just, I can tell you, every single one of these companies have bean counters that know what parts are going to be popular, and I would be surprised if you're able to find these easily at MSRP. Because let's not forget, the 7800X3D did find its way over $500 at one point. It's what happens when there's just no competition. And it's also what's gonna happen when Intel doesn't have a true competitor to this CPU, especially considering the fact that the 265K is $399, but its performance gap between this is greater than the performance gap in price. So if you take the $400 265K and you compare how much percentage-wise cheaper that is than the 9800X, the performance is greater difference than that number. So the 9800X3D for anyone building a gaming system is the CPU you're gonna wanna buy. Because of that, prices are unfortunately going to probably be through the roof on day one. Let's talk about the actual power draw, temperatures, and all that sort of stuff. So let's start with Cinebench R23 multi-core 10-minute test. What I find interesting about this, the 7800X3D, you can see hits 4.8 gigahertz and then just, it's pretty solid line with a couple of heartbeat blips above it when the test is reloading because it can go into single and two-thread workloads and get a little spiky there. It's the way Turbo Boost works. But if you look, our 9800X3D is staying around the 5.2 gigahertz mark through the entire test. You don't see those little spikes because it's going all the way to its turbo max, kind of out of the box without touching anything, even in a multi-threaded workload like Cinebench R23. What I also want you to notice is the beginning and the end of this chart. The 9800X3D starts at a lower frequency and surpasses the 7800X3D through the entire test, and then as soon as the test is over, drops down to a lower frequency once again. So that's gonna equate to things like lower temperatures over time because it's doing spiky workloads with things happening in the background. When the test is done, it's automatically using less power, less temperature because we're able to get the heat out of the CPU core that much faster. It's gonna be more efficient, not just temperature-wise, but power draw-wise, all of it. Now, if we take a look at the temperatures in that same 10-minute run, you can see though, the 9800X3D's temps are higher on average. There's a reason for that. One, remember, it's going all the way up to 5.2 gigahertz, not 4.8, which is what the 7800X3D is doing. Two, it actually is able to get closer to that 162 watt PPT because of the fact that the cooling is there. So because the cooling is there, it also means that you're able to push the limits all the way to the max turbo clocks, which is where it wants to be at 5.2 gigahertz. What I think is interesting too is in the middle of the 7800X3D test, I wonder if a background update or something potentially started, even though we do pause updates. You can see a lot more heart beating in the middle and then it comes back down to normal. But what I think is really interesting too here is if you look at the dips, because every time the test restarts, the Cinebench test restarts, it has to reload the test so the load drops off and then it goes multi-load again as it starts the test. You can actually measure on this chart how much faster the 9800X3D is completing the test by where the starts and stops are. So that's why it actually ran a little bit longer, because it was able to get in an entire additional test in that 10-minute period just by the fact that it was performing that much faster at completing the test. So I thought that that was interesting by looking at this chart. If we take a look at the wattage power though, as you can see, our 7800X3D, this is package wattage, not just core watt, but the whole thing, the IO die, the cores, the cache, everything encompassed in one. The 7800X3D was pulling about 84 watts, and our 9800X3D was pulling about 145. So I thought that was interesting, but we ran the test several times. Remember, it does also have a 162 watt PPT on the 7800X3D as well. However, it has a much lower max turbo frequency available to it. So it was hitting the frequency before it was hitting the power limit. Again, the limitations of having the cache on top of the core die, or the core itself. That's one of the reasons why, if you take a look at temperatures, it actually runs about 10°C hotter in a multi-core workload, the 9800X3D anyway, because of the fact that it is pulling close to double the amount of watts. So that's actually pretty impressive. If you think about the fact that it's maintaining 5.2 gigahertz all the way across the test, no throttling whatsoever, 145 watt package limit or package power across the board, and the fact that it's able to maintain those clocks the entire time. So you can see, we also correlated this data with looking at Tom's Hardware's reviews, even Gamers Nexus reviews with the 7800X3D when it first came out. This is aligned with what other people were seeing with actual package power draw in the 80s, some as high as 90 when it comes to these tests. So it's just the way the CPU was designed that core frequency was what it was hitting before it was ever hitting power limit. OCCT charts are very, very boring because they're just straight lines. So the core clocks, once again, in OCCT, it's actually a little under 5 gigahertz when it comes to the 9800X3D. That's because it's a multi-workload. It does the AVX instruction. It actually will reduce the core clocks a little bit in AVX2 instructions because of workload, just the way AVX works. But as you can see, we are at like 4.38 gigahertz on the 7800X3D, and we are at 4.8 gigahertz on the 9800X3D. So nearly 500 megahertz difference right there. If you take a look at the temperatures though, once again, it's the same sort of story. Almost 80°C, it's about 77°C on the 9800X3D, and actually under 60°C on the 7800X3D. Same reasons we already talked about. It's hitting that frequency limit so early because of the core sensitivity to temperatures that the frequencies are so low out of the box that it's just not great in this type of task, which is why it's actually low power draw, low temperature, because of the fact that it hits that cap so hard when it comes to the turbo frequencies. If we take a look at the wattage though, here it is again, right? Just over 80 watts at OCCT's 30-minute test. Almost 150 watts straight across the board for the 9800X3D. So it's able to just more leverage the proper wattage. It acts like a normal CPU at this point. In fact, that's why you can overclock the thing, which you cannot do on X3D CPUs. Haven't even touched that yet. I need to figure that one out. Really want to play with it and see what we can do out of that. But if we take a look at the Cyberpunk 2077 in 1440p Ultra with DLSS set to quality to see what power draw and all that looks like in actual gaming scenarios, it looks broken because it goes to 5.225 or 5,225 megahertz locked across the board, completely flat. Not even one little blip, not even one fluctuation. It is just 5225 the entire way. That is awesome. Because if you look at the 7800X3D in the green line, it's all over the place because of the fact that it is hitting those other limits early, like I said. So this is why the FPS improvements are really there, because the CPU is handling all of that workload from the GPU, and it's doing it without breaking a sweat. So it's just maintaining those clock speeds, which actually looks really boring on charts, but it's exciting to see very little, if any, fluctuation at all. If we take a look at the package temperatures, in gaming, it is actually significantly cooler than the 7800X3D. That was where it was interesting. I was expecting, because of in the compute test of it being so much warmer than the 7800X3D, that might be the case as well when it comes to the games. But no, because that die is right against the IHS and it's not being insulated by the cache array, it is getting a more efficient transfer of heat in this lower wattage, lower demanding workload, which games are for this CPU. So as you can see, it is averaging less than 55C in games, in Cyberpunk specifically, which uses a lot of CPU for all the NPC and world threads and such. If you compare that to the 7800X3Ds, what looked to be really good back in the day of like 63C, seeing 54 to 55C is a pretty significant drop in temperature. And if you look at the power in games, it's drawing more power to do it. So this is where it's just like a little mind-blowing, because it's not that linear thread of more watts, more temperature and multi-threaded workloads for CPU, like in compute, does not transfer over to games. It was actually more power, as you can see here, averaging about 95 watts or so on the package, versus 7800X3D's 77 watts, and it's colder by nearly 10 degrees. That's why the 9800X3D is actually such an exciting CPU. For me, not the fact that the 9800X3D is that good. It just has me really, really hoping for some new things for the multi-CCD CPUs. Again, I think what we're really holding out here for is for the 9800, or excuse me, the 9900 and 9950X3Ds to be cache array on both CCDs with the full Monty of power and boost clocks and all that available to it, because then you'll get a much better jack of all trades type of CPU. And that is what's gonna be, honestly, the final nail in the coffin, I think, when it comes to where Intel can currently compete until Intel's Core Ultra tiled architecture really starts to mature. This is the inverse of what we're used to seeing with AMD versus NVIDIA when it comes to GPUs. AMD has been about an entire generation behind on everything NVIDIA has done when it comes to GPUs. They were second to real-time ray tracing. They were second to any sort of AI rescaling. So they've always been in the shadow and the coattails of what NVIDIA has been doing. But this time around, AMD is so far ahead of the multi-faceted CPU architecture that it is gonna be really interesting to see what the next 2 to 3 years look like when the next generation of Intel CPUs come out, to see if they can even close the gap on what Intel or AMD has already put in the market in terms of performance differential in games. Anyway, there you go. There was a lot to talk about in this one, but if anything, I think the 9800X3D is a little backwards too, because remember last time we got the 7950X3D and the 7900X3D first, then the 7800X3D came out, then the 5800X3D came out. So this time they started more where they know people want it, and then people like me who want the big boy CPUs to see what that's gonna look like, I can't wait. And I'm really hoping it's sooner rather than later, because this is the quickest we've seen an X3D architecture make its way to market from the new family launch. It's only been a few months. So there you go, sign off, don't sign off yet. Comment down below if you're excited for the CPU, if you're a little disappointed in the fact that it's not as big of a performance gap as you were hoping for, or if you're just like, so excited, you just can't contain your excitement like me right now.